Okay, so this is IMTL 116 lab, and we're going to be talking today about transfer gauges. So in your lab, we'll be taking our plates right here that have the depth steps in them, but also have the holes in them. So half of this lab is using your depth micrometer to check the depth of these holes. The other half of this lab is going to be to use a transfer gauge. Now, the size of these holes, we have a problem. We'd like to put a micrometer in here, but micrometers work on the outside. So we do have certain kinds of micrometers called inside micrometers, which we'll be showing you at a later date. Depending on the hole size, you may not be able to get an inside micrometer in there. This hole right here, which is the largest hole in the plate, it possibly could fit an inside micrometer in there, a very small one. And an inside micrometer is perhaps the most accurate of the micrometer methods to measure this. However, any of these smaller ones, there's no way an inside micrometer is going to get in there. Different ways that we can measure the hole. We have bore gauges, we have air gauges, we have gauge pins, which are perhaps the most accurate way to measure them. But those aren't always readily accessible. For example, a gauge pin would be sets of round gauges that start at about 20 thousandths and go all the way up to, oh, I don't know, however high you want to go. And going up to an inch is pretty common in the shop. And they go by 1,000th increments. So if you are lucky enough to have a large set of gauge pins in your shop, you can go over, pull pins out and start checking the fit of that pin in a hole until you find the one that fits just right, goes in but no shake on it. And that's a very accurate way to gauge a hole. That's not real practical. The gauge pin sets for the average machinist are not really affordable. Shops will have them, but you know, a lot of times we just need something that's in our toolbox that we can easily measure. So inside micrometers work pretty well. Transfer gauges, however, allow us to use our micrometers that we already have and transfer an inside dimension to be able to measure it outside with a micrometer. So let me show you what transfer gauges look like. I'm going to show you a couple kinds today. This is a set of transfer gauges, and you open it up and it's got about 5 different transfer gauges in. Sometimes we call them T gauges. T could stand for transfer. It also could just mean the shape of these type of gauges. So I'll pull one out here. This is a very large transfer gauge. It's got a handle here and it's got a little brake here. I can turn that and it will lock this telescoping head here. Now, I call it a telescoping head because it's spring-loaded. We can push it in to make it very small to get it inside of a hole, and then we let it expand out to the size of the hole. Once it gets there, we can kind of tighten it up so that we can then pull it out of the hole and measure it. And we'll get a little more into the technique in a moment on doing that. Obviously, this is a very large one, and this right here would be about the smallest hole it could go into. If I look at the set, it will tell me, and it says that this one goes from about 3 1/4 up to 6 inches. So none of the holes that I have on this plate are small enough for this gauge. So let's look for the ones that actually would fit it. I'm going to pull out this one here. It's the B gauge, and it says that it goes from about 3/4 of an inch to 1 1/4 of an inch. And we're going to measure this hole right here. So I'm going to take this gauge, and the way I'm going to do it is I'm going to squish it so that it telescopes in, tighten it just a little to stop it from springing out, and then I'm going to insert it into this hole. And once it's in this hole, I open the gauge up, I release the brake so that it expands in the hole, and I'm going to hold it at just a slight angle. Okay, and I'll talk about why the angle in a second. So now I'm going to tighten it up, and I'm going to sweep it out of the hole. Okay, once it's swept out, I can take my micrometer and measure it. Now let's talk about that angle and why we do it. Theoretically, I could put this gauge in here and just open it up until it expands to the hole, and it's kind of self-centering because it'll the spring-loaded tendency of it will move it to the very center of the hole. However, the problem is that I can't guarantee that I'm holding it at an exact angle. The best way to manage that would be to, I'm going to put this up right here. Let's adjust my camera a little bit. There we go. The best way to manage that would be to somehow hold this perfectly straight. That would take some kind of a device to make sure that this doesn't deviate at all. However, what we can do, so that's not really practical. What we can do, though, is we can hold it at an angle like this. It's got a slight angle to the hole. Put a little bit of tension on it. And then if I sweep it out in the same plane that the gauge is going across the hole in, the gauge will close, it'll compress the telescoping head until it reaches the smallest point. And then as I go across that smallest point, it'll just kind of stick there. Once that's done, I tighten it just a little more because I don't want it to move when I get my micrometer out. And I adjust it and find this. Now, there's a couple places to make an error in here. Just in your hand manipulation to get that to sweep across is a good opportunity to mess this up. So you got to be very careful in how you do your method there. And then the second thing that I can easily make a mistake on is I'm taking that T gauge now and I'm putting it into a micrometer, and I've got to carefully adjust the micrometer down until it just touches the gauge. And then I back it up and keep moving that gauge around until I get just barely touching, but not sticking. And I'm going to call that good right there. I'm going to look at my results. Actually, I moved it as I moved my micrometer. So let's try it again. I'm sweeping the transfer gauge through there until I find just the right touch amount of feel in there. And I'm going to call that good. I look at my micrometer and I am at 0.9, 50, and then 15. So I've got about 0.965. Now, one measurement would not be good enough to guarantee that that's what the hole size is, because, like I said, we have a pretty good opportunity to make a mistake in how I maneuver this across the hole. We also have an opportunity to make a mistake when I'm trying to get just the right feel by moving this in here. This is a lot more tedious and takes a lot more manual dexterity than using a micrometer on an outside dimension like a round diameter piece of stock or something. So I got 965. The way I'm going to know that I got this right is I'm going to have to do it 3 times. And if I get the same result 3 times in a row consecutively, there's a pretty good bet that that's the right number. So I put it into the hole at a slight angle, and then I tighten it up, and then I sweep it out in a plane that's in line with the telescoping head, and then I measure it. And I look at it and I got 0.965 again. Okay, so that's a pretty good guarantee that, or not guarantee, that's a pretty good indicator that I'm on the right track. I haven't made a good major error yet. So I'm going to open this transfer gauge up again one last time, tighten it down, and sweep it through the hole. Tighten it just a little more. The reason I tighten it just a little more is my micrometer is going to put just a little bit of pressure on there, and I don't want it to compress that telescoping head any. And I got 0.965 again for the last time. So I'm going to say that that hole is a 0.965. When used properly, transfer gauges can be extremely accurate. Now let me tell you the places where people make mistakes on these. When I put this in here, and I put a little bit of an angle on it, and I tighten it down, If I sweep it at an angle that's not, or excuse me, sweep it in a plane that's not in line with this telescoping head, it's going to give me a bad reading. It's going to give me something wrong, okay? So I've got to make sure that I'm watching carefully, looking at the plane that that head is, and make sure my sweep happens in that same plane. Okay, and then I pull it out, tighten it just a little, and measure it. Now, the next place that people make a mistake, and we talked about this, is not moving it around until you get just that right feel. Now, good transfer gauges have a little bit of a radius on the ends, and what that allows it to do is only have one place where it will touch the micrometer that is a correct reading. So make sure you really take your time and develop a very soft touch in how to do that. Now, your transfer gauges, I've got them small size. I think I can go from about 1/2 inch all the way up to 6 inches with this one set. These are the T gauges. Couple things you want to be careful. Don't over tighten this. If you put too much pressure on there, when you try to sweep it to compress it, it bends the stem a little bit. It also drags those telescoping heads past that break so hard that it scores them and can cause damage to them. So it's all about being delicate. Now, the other thing is you don't want to leave them too loose so that the second you pull them out of the hole, they kind of spring out a little bit. So it's about developing that feel. This is a Starrett set, and it is a very good quality set. Highly recommended. T gauges are one of those tools where there is a vast difference between a cheap import sets and a high quality Starrett set. And by import, I mean like made in China or Taiwan or somewhere like that. Import from Japan is top notch. So Mitutoyo is the way to go. Okay, so that gets our larger holes in here. We can measure those with a 1-inch micrometer, most of them. A couple of them are a little larger. We have to measure them with a 2-inch micrometer. Now let's go to small hole gauges. Now I have 2 kinds in front of me. Let me pull out this import set here first. A lot like our T gauge in function, but it does have a couple of differences. Instead of sweeping it through the hole, I can turn this little end and it causes a wedge to pull down, which spreads out this little head here. Okay, so instead of trying to sweep into a hole, I'm going to put this, and let's use this hole right here, if I can get it in there. I'm going to put this in, and I'm going to hold the body with one hand and the adjuster with the other hand, and keep turning it until it just touches inside of the hole. Okay, now it's touching the hole in there. And then I'm going to back it off. Right there, it's too free, so I'm going to tighten her up just a little more. I just want an ever so slight drag on that hole, and I mean very slight. Okay, and that has then brought my diameter of that hole out on a transfer gauge to something I can measure with a micrometer. I'm going to bring my micrometer in, and then I'm going to measure this end of it. And on that particular one, I got about 0.398. Okay, and of course I would do the same thing with that one. I want to do it 3 times, you know, loosening it and then starting over, adjusting it till it's just right, and then check it with my micrometer. If I can get 3 measurements that are the same in a row, then I'm going to call that my measurement. Okay, so that's pretty good. Now I've got 2 kinds right here. I said this is the cheap little import one, and you'll notice, I'll put it up nice to the camera here. It's actually, if the camera can focus on it, it's just stamped steel that's just got a flare on the end, and then it's got a little wedge inside of there that kind of moves in and out. This is what we would call low quality trash. Okay, they don't cost very much. They don't measure real good. They don't give you a good feel. For one thing, being that it's a wedge, it kind of pulls against the hole good one way, but when you push it in, it doesn't have the exact same feel. So this is not real useful in my opinion. I don't like the feel of these. Maybe I'm a little bit of a tool snob. No, I'll say not even maybe. I am a tool snob. I like high quality tools. This, on the other hand, is the real deal. This is a Starrett. Again, Starrett makes some excellent products. And instead of being a little stamped steel wedge, this is actually a machined ball that, again, has the little wedge that when we pull it, it spreads the ball out. What makes this one so much better is it's a ground ball, so it's very consistent all the way around it, and it's got radius going all the way around. So when I put this one into the hole, I'm going to back it out so it fits in the hole, and I tighten it up till I get just that right feel. So much better of a feel. Okay, I can do something with that. I have much better control over it, and I have much better sensitivity. And then when I go to mic this ball, instead of having to guess if I'm right on the plane that that wedge surface is setting on, I can easily just mic down because it's a radius. Okay, and I got actually 0.399 on that one, so that's 1/1000th larger than I got with the wedge. Again, measure 3 times to make sure you're consistent, and then you can record your. Let's talk about what's wrong with these now. Okay, so this little ball spreads out, and I can get a pretty good feel on the whole. Okay, so where I left off on the last video is we were talking about some of the problems that come with measuring with a transfer gauge like this. My internet's not real great at home, so it kind of cut me off. So picking up where we left off, the problem is it expands out, and there's only one spot that represents the hole that we're measuring. So if I get this just a little bit off, then that's a problem. So my solution to that is I'm going to rotate the ball until I find just the right tight spot. Okay, and that's right there. And then I've got another issue where I don't know how straight this was to the hole, so now I have to rotate the ball back and forth until I found that soft spot. So I got 2 ways that I need to rotate it so I can get just the right feel and read my micrometer. So those are transfer gauges. There's lots of different ways to measure a hole. Transfer gauges are actually a pretty affordable one. When you consider that we already have micrometers that are extremely accurate, this represents not having to buy a whole nother set of very specialized micrometers to measure inside of a hole. We're just going to be able to transfer this to a regular micrometer. So very good for cost savings, very handy, very versatile. However, it does have some errors that can potentially spring up. So that's what I've got for this one, and I'll see you next week.